So I go, hello. Yeah, they're going to love that one. All these people that are gone. Okay. Here we go. Derivatives of sine and cosine. We're going to start with sine and cosine. We'll end with secant and cosecant and tangent and cotangent later. All right. The derivative of the sine of x is the cosine of x. Boy, that's easy. Hi, Miss Lindsay. The derivative of the cosine of x. Oops. The derivative of the cosine of x is negative sine of x. So what would be the derivative of x cubed minus cosine of x? Well, it would be the derivative of x cubed minus the derivative of the cosine of x, right? What's the derivative of x cubed? 3x squared. What's the derivative of the cosine of x? Negative sine of x. Minus the negative is plus the positive. Okay? Easy peasy, lemon squeezy. You'll see that trig functions, oh, they're so easy to do. But not as easy as e to the x. Because e to the x is the easiest one. 8 sine of x. What's the first derivative of 8 sine of x? 8 cosine of x. What's the derivative of x? One. Easy peasy lemon squeezy. This stuff is so easy. So sines and cosines are going to be really easy for you. Okay. The ln of x. The first derivative of the ln of x equals 1 over x. So the ln of 5 is 1/5. The ln of 8 is 1/8. Okay? But even easier yet is the first derivative of e to the x. And that is e to the x. The derivative of e to the x is itself. What's the first derivative of 3x to the fourth? 12x cubed. What's the first derivative of 7 ln of x? 7 over x. Because it's 7 times 1 over x, which is 7 over x. Easy peasy lemon squeezy. What's the first derivative of 2e to the x? 2e to the x. What's the first derivative of cosine of x? Negative sine of x. So the first derivative of negative 5 cosine of x would be plus 5 sine of x. What's the first derivative of 3? 0. So it's just that. The 3 gets dropped. Okay? Got that? Okay, so that covers like 3 assignments. And then you have the product rule. If you have two things multiplied times each other, so if f of x equals g of x times h of x, the first derivative of that function would be g of x times the first derivative of h of x plus h of x times the first derivative of g of x. Okay, let's put the product rule into motion with this. The first derivative of this, well, this is your g of x, and this is your h of x. So it's your g of x times the first derivative of your h of x. What's the first derivative of ln of x? 1 over x, plus your h of x, ln of x, times the first derivative of x squared, which is 2x. Now, what's x squared times 1 over x? What's x squared over x? 1x, because the x is canceled. Okay? So, and then this one you write as 2x ln of x in that order, not ln of x 2x, because then it thinks you're taking the natural log of 2x. So you put that out front. So this is a proper way of writing it. That's simplified. Okay. Now, before I start this problem, I see 1 over x and I say, oh, that's not good, written like that. It should be x to the negative first power cosine of x. Now it's written in a way where I can take the derivative. All right, so what's the first derivative? Or you take the first one, because this is g of x, x to the negative first, times the first derivative of cosine of x, which is negative sine of x, plus the cosine of x times the first derivative of x to the negative 1, which is negative 1x to the negative 2. Now, I think Khan Academy would actually take it like this, but I would rather see it as x to the negative first is 1 over x, right? So it's negative sine of x over x, because it's 1 over x times negative sine of x, plus, or minus, I should say, because we have a negative 1 there, minus cosine of x over x squared. That's how I would like to see it written. That's the product rule. The first times the first derivative of the second, plus the second times the first derivative of the first. Now, if we have tables involved and numbers involved, this is not that hard. So, let's rewrite this in the product rule. So this would be f of x times what? First derivative of g of x plus g of x times first derivative of f of x. So f of x is 3. First derivative of g of x is negative 3. Plus g of x is 2. Times the first derivative of f of x is 7. All from the table right here. Just grabbing the numbers, putting them in. Negative 9 plus 14 equals 5. Easy peasy lemon squeezy. Okay, so this would be f of x times the first derivative of h of x plus h of x times first derivative of f of x. And you look at the table for the numbers. Negative 3, 3 plus negative 4, 1. Negative 9 plus negative 4 equals negative 13. Easy peasy lemon squeezy. All right. Bless you. All right, so we're supposed to evaluate this at 9. Okay, so this is g of x times the first derivative of h of x plus h of x times the first derivative of g of x. Okay, what is g of x? Well, if it's at 9, g of x would be 0 times the first derivative of h of x. Well, h of x is the square root of x, right? So h of 9 would be the square root of 9, which would be 3. Now, what's the first derivative of h of x? Well, the first derivative of this is x to the 1/2 would be 1/2 x to the negative 1/2, or 1/2 over times 1 over the square root of x. Well, if we put in a 9 there, what's the square root of 9? So it's 1/2 times 1/3, which is 1/6. So that's the first derivative of h of x. Now, did we have to figure that out? No, because 0 times anything is 0, but we did anyway, so you would know for the future. Okay? Now, what's h of 9? 3. And the first derivative of g of x is 2. So it's 0 plus 6, which would be 6. One more of those. What time do you leave, Garrett? Oh, that stinks. Okay. So h of x is 1 over x. So h of negative 2 is negative 1/2, correct? If you put in a negative 2 there, you get negative 1/2. The first derivative of h of x is x to the negative first. So it would be negative 1 x to the negative second, or negative 1 over x squared. If you put in a negative 2 there, it'd be negative 1 over negative 2 squared, which is negative 1/4. So to do the derivative of the product rule, f of x times h prime of x plus h of x times f prime of x. What's f of x? The first, so f of negative 2 is negative 8 times a negative 1/4, because h prime of negative 2 is negative 1/4, plus h of x. H of x would be negative 1/2. First derivative of negative 2 is 4. So this is 2. This is negative 2. Works out to be 0. Okay, so that's your first set of assignments. Now, Garrett says he has to leave, and I should teach both lessons at the same, right after each other, and then give you the rest of the time to work. Okay, we'll do it that way. Okay, so that's the product rule. Then there's the quotient rule, which is that. It's kind of like the product rule, except for it has a minus sign in it, and then you divide by the denominator squared. That's the quotient rule. Now, these are on your sheets on the front page. Okay, but also you're going to be using these so much, you need to practice with them. Quotient rule. Little harder than the product rule. Product rule is fairly simple. Quotient rule, a little harder. So you take the bottom times the first derivative of the top. What's the first derivative of x squared minus 2? First derivative of x squared minus 2. 2x. And then you go the minus the top, x squared minus 2, times the first derivative of the bottom. What's the first derivative of x minus 1? 1, because it's the first derivative of x, which is 1. 1, the first derivative of that is 0, so that disappears. Divided by x minus 1 quantity squared. So you should simplify the top. So this is 2x squared minus 2x minus x squared plus 2. The bottom, just leave as x minus 1 quantity squared. So the top, what's 2x squared minus x squared? X squared. So it's x squared minus 2x plus 2 over x minus 1 quantity squared. That one wasn't so bad. Some of them get complicated. This one will be a little bit more complicated here. So the quotient rule is the denominator, 2x plus 7, times the first derivative of the numerator. What's the first derivative of that numerator? Four x plus 1 minus the numerator, 2x squared plus x minus 3, times the first derivative of the denominator, which is 2, over 2x plus 7 quantity squared. So the denominator you don't mess with. You just leave it as that. But the numerator, you don't leave it like that. You got to distribute, solve, or not solve, but simplify. So, numerator looks like we have to FOIL. So it's 8x squared. Outers and inners is 2x plus 28x, which is 30x. Last times last is plus 7. Minus 4x squared minus 2x plus 6. Because I distributed my negative sign and I multiplied by 2 everywhere. So you multiply by 2. That's how we get 4x squared plus 2x minus 6. And then I have to distribute my negative sign everywhere. So that's why it's negative 4x squared minus 2x plus 6. So then in the end, I get 4x squared plus 28x plus 13 over 2x plus 7 quantity squared. Okay, so it says find the first derivative of this at 0. Well, I got to do the derivative. So it's the denominator times the first derivative of the numerator minus the numerator times the first derivative of the denominator over the denominator squared. At this point, I wouldn't mess with trying to simplify the top. I just put the 0 in. So if you put 0 in here, you get negative 1. You put 0 in here, you get 0. You put 0 in here, you get 5. You put 0 in here, you get 0. You put 0 in here, you get negative 1 squared. So it's 0 over 1, which is 0. On this one, take the denominator, which is 3x squared minus 4, times what? 2, the first derivative of the numerator, minus the numerator 2x plus 3 times what? 6x, because the first derivative of the denominator, all over 3x squared minus 4 quantity squared. So if we put in a negative 1 in each of these x's, negative 1 squared is 1. 3 times 1 is 3 minus 4 is negative 1. Negative 1 times 2 is negative 2. Minus 2 times negative 1 is negative 2 plus 3 is 1. 6 times negative 1 is negative 6. Over negative 1 squared is 1, so it's 3 minus 4, which is negative 1 squared. So it's negative 2 plus 6, which is 4 over 1, which is 4. Quotient rule. Takes a little bit to work through. Quotient rule for this one. This one isn't bad. Quotient rule is the denominator times the first derivative of the numerator plus the numerator times the first derivative of the denominator over the denominator squared. So it's negative x sine of x plus cosine of x over x squared. Easy peasy lemon squeezy for that one. What? Way to go, Caitlin. This one is x to the 1/2. Because the square root of x is x that. So it's x to the 1/2 times the first derivative of the numerator, cosine of x, minus sine of x, times the first derivative of x to the 1/2 is 1 over 2 square root of x. You're going to learn that the first derivative of x to the 1/2, or the square root of x, is 1 over 2 square root of x, because you're going to hit that so many times. Okay? Because it's 1/2, x to the negative 1/2, and x to the negative 1/2 puts the square root of x on the bottom. The square root of x squared is just x. So we have the square root of x cosine of x minus 1 over 2 square root of x sine of x over x. The problem with this is it's a complex fraction, right? So I'm going to multiply my denominator by 1 over x and my numerator, everything in my numerator, by 1 over x. These cancel. So I get the square root of x over x cosine of x minus 1 over 2x square root of x sine of x. This is my final answer. We getting the quotient rule now? No. So the quotient rule is the denominator. What's my denominator here? Cosine of x times the first derivative of the numerator. What's the first derivative of e to the x? It's the easiest one in the world. E to the x. Minus the numerator, e to the x. times your first derivative of the denominator, which is negative sine of x. Because the first derivative of cosine is negative sine over cosine squared of x. And all we do is cosine of x, e to the x. Or I suppose I could put the e to the x up front. E to the x cosine of x plus e to the x sine of x over cosine squared of x. Quotient rule. What? Minus a negative is a positive because we're multiplying them together. Nine.
Oh my god. Is this supposed to be in trig boxes or something? No, it's because Gary has to do it all at once.
Oh my goodness, I've never heard Carson talk like that. Okay, last one of these like this, then we'll do a couple table ones, and then we'll look at the cofunctions. So ln of x, no, but we're behind. So we got to catch up. Ln of x times the first derivative of the numerator, negative sine of x, minus the numerator times the first derivative of the denominator over the denominator squared. So negative ln of x sine of x minus 1 over x cosine of x over ln of x squared. So it's not that big of a deal, the order, but we usually write sines and cosines last. Now, on this one, to simplify this one, because we got a complex fraction, a fraction within a fraction, what I'm going to do is multiply the whole numerator by x to get rid of the 1 over x, so I have to multiply the whole denominator by x. And if we distribute through there, we get negative x ln of x sine of x. These two cancel, so it's minus cosine of x over x ln of x squared. And that would be our final answer. Okay. All right, so for this one, I want to do the quotient rule. What's the quotient rule? Well, it's h of x times the first derivative of g of x minus g of x times the first derivative of h of x over h of x squared. Correct? Now you just put in the numbers. Negative 2 times 8 minus 7 times 4 over negative 2 squared. Negative 16 minus 28 over 4, which is negative 44 over 4, which is negative 11. Okay, so here, g of x is 5, g prime of x is 6. H of x is, if we put a -1 in there, -1 squared is 1, times 2 is 2. H prime of x is 4x, so it would be -4. Correct? We just made our table. Now, we go through it. So it's h of x times g prime of x minus g of x times h prime of x all over h of x squared. So it's 2 times 6 minus 5 times -4 over 2 squared. Or -12 plus 20 over 4, which is 8 over 4, which is simply 2. Ooh, that should be positive 12, right? So it's 32 over that, which is 8. What? H of x? Plug -1 into that function. All right. And the last of it, the tangent of x, and I forget these sometimes, but I'm pretty sure tangent of x is secant squared of x. It's on the front page of your thing. So tangent of x, yep, is secant squared of x. On your tests right now, yes, but not the AP test. You will take quizzes over this, like quizzes on memorizing this, memorization quizzes, because you'll have to memorize all this stuff when it comes to that time. So d dx of tangent of x is secant squared of x. Easy peasy. And d dx of cotangent of x is negative, is it negative cotangent of x cosecant of x for cotangent of x? Oh, negative cosecant squared of x. Okay. And then secant of x, the first derivative of secant of x is secant of x tangent of x. And the first derivative of cosecant of x is negative cosecant of x cotangent of x. So the first derivative of secant of x is secant of x tangent of x, right? So we're just going to find the secant of pi, the tangent of pi. Well, on our unit circle, pi is at -1, 0, right? So the secant at pi is 1 over -1, which is -1. The tangent at pi is 0 over -1, which is 0. 0 times -1 is 0. Okay, you have enough stuff to keep you busy for several hours. Okay. So this is it for this chapter. We're going to be testing next week already. Next week, we will test over this. Sorry.